Alright, so welcome to this next video. Today we're going to be talking about dividing quantities into a ratio. So we've just finished looking at ratios and how they generally work and simplifying them. But now we're going to look at dividing quantities into a ratio. Okay, so particular quantities can be divided into a set ratio, and it's quite a simple process, and already our knowledge on the unitary method with percentages has really set us up for doing this same kind of thing with ratios. So couple of key ideas again. First, that ratios should be thought of in parts. Okay, so we've seen before that 3 is to 7 means 3 parts of one quantity and to 7 parts of another, which equals obviously a total of 10 parts, because 3 plus 7 is typically equal to 10. Now, once we sort of know these ideas and what's going on with that particular ratio, we use the unitary method like we did for our percentages to reduce the quantity to one part, then expand it up into necessary ratios. So with that first little thing here, you would reduce down to a single from 10, and then times by 3, times by 7, that kind of process. We'll see that happening in a moment. You can also use fractions to divide the quantity. And so you would find the total number of parts and the number of parts for that ratio. So as we have up before here, parts 10, 3, and 7. And the fraction of the whole required is the fraction, is the number in the ratio over the total number of parts. So up here, we could have a fraction being 3 over 10, or a fraction 2 being 7 over 10. Okay, set 3 parts in 10, 7 parts in 10. Okay. Right, to find a whole quantity from a ratio, then you use the unitary method sort of backwards, and you'll see that happening in a moment. Right, a couple of examples. Divide $56 into the ratio 3 is to 5. So first off, we want to ask first how many parts. So the number of parts equals 3 plus 5, which is 8. Okay, therefore, one part equals 56 divided by 8, which is 7. Okay, therefore 3 parts equals 3 times 7, $21, and 5 parts equals 5 times 7, which is $35. Okay, and then in the end, we could say that $56 was divided up into $21 to $35. Okay, so that's sort of the process. See how we got the unitary method going on here. Here we are, this is our reducing, and then we're expanding into our necessary parts here. Okay, very, very, very easy to do. Right. So another example is that we divide 250 milliliters into the ratio 5 to 4. So we have first the number of parts equals 5 plus 4, which is 9. Okay, 9 parts. Therefore, one part equals 250 milliliters divided by 9, which is equal to 27.7 recurring milliliters. Okay, right, so now that we found one part, we have reduced from our whole of 250 milliliters into a single part, and then we need to expand. So we're expanding into our different ratios of 5 first. So therefore 5 parts equals 27.7 times 5, which gives us 138.9 milliliters. And 4 parts is equal to 27.7 times 4, which is 111.11 milliliters. Okay, so for this one here, we've gone from 250 milliliters has been turned into 138.9 milliliters is 211.11 milliliters. Okay, now even though I've represented these two in fractional amounts here and here, these ones, it's kind of okay because it's sort of the answer, the ending up where we're going. It's not the full simplified ratio. Okay, full simplified ratios are the whole number amounts. Okay, lastly, this is sort of that backwards method I was talking about before, where you're going from a ratioed amount up back to its full amount, kind of. Alright, so Dana can recall that the ratio of flour to sugar in her ultra-sweet cookie recipe is 3:8. If she has 4 cups of flour, how many cups of sugar will she need? So, let's sort of unpack this. We know our ratio is 3:8, which is flour is to sugar. Okay, now what that means is that there are 3 parts flour to 8 parts sugar. I did say this was a super sweet cake. Now, if she has 4 cups of flour, how many cups of sugar will she need? Well, when we're doing these ratio kind of problems, essentially the first thing you want to do, you want to ask is, how much, what quantity is 1 part? Okay, so first off, our step's always going to be asking ourselves, what is the number of parts? Well, the total number of parts is 3 plus 8, which is equal to 11 parts. Okay, right, that's just a piece of information that we should probably find out. Turns out in this one we don't actually need to know it, because we've been told but 4 cups is 3 parts. Okay, therefore 1 part equals 4 cups divided by 3. Okay, so 1 part is equal to 4 over 3. Okay, right, now that we've got the 4 over 3 cups. Okay, now we've got 1 part. We needed to find out how much sugar she needs. So our ratio is 3:8. So for every 3 parts of sugar, there is 8 parts of flour. Sorry, every 3 parts of flour, there's 8 parts of sugar, sorry. And now that we've found out the amount of 1 part, we've gone from 3, reduced down to 1, and now we need to expand back out to 8. So therefore, 8 parts is equal to 4/3 times 8, which is 32 over 3, which is 10 2/3 cups, okay, of sugar. Okay, and probably this is a nice little wordy problem, so you might want to write therefore she needs 10 2/3 cups of sugar. Alright, so that's sort of a couple of examples of how ratios sort of work, the kind of problems that you'll end up running into. Being able to rest with this stuff will help you later on in life, I do promise that, because ratios is something you'll have to work with, and being able to do it quickly will just make your life a lot easier. So hopefully you've seen in this video that they are very closely related to how I've been working with percentages, and the unitary method, quite honestly, is the easiest way to work out your ratio problems. So I did say earlier that there was a fractions method of doing it. Essentially you're doing about the same amount of work, but I think that it's best to go the unitary method, more probably easier for you to grapple straight away and work well with. Okay, so I hope you've enjoyed that video, and please come along to class if you have any extra issues. Maybe even try some of the problems from that chapter before you turn up. Okay. Thank you.